Thank you very much, Timur, and thank you very much, Doug. We're now going to dive into our first technical session, after which I will run through the rest of the agenda. But right now, I'm going to introduce the next presenter, which is Gustavo Vinueza. He's the Director of Training and Consulting here at the Ferryfield Group. Another face many of you will be familiar from the years at Palisade. So Gustavo was a head of training and consulting at Palisade for many, many years, over a decade, and has got 15 years experience in Q&A. Gus has trained and consulted with teams all across the world in most industry sectors, from infrastructure to energy, from like insurance to oil and gas and mining. Is an expert in showing how to apply QRA in many, many situations. So in this particular session, Gus is going to walk us through how to simulate cost budgets using ModelRisk, taking us from the base model to risk-adjusted outputs, and how these outputs enable informed decision making. And so please join me in welcoming Gustavo.
Hello, everyone, and thank you, Craig, for the intro. Just for you to know, we're following the agenda here. We are in this simulating cost budgets with ModelRisk. So I'm going to have more like 30 minutes, because I know that the presentation was over a little bit, but you please let me know if you need anything, and please feel free to send your questions in the Q&A and in the chat. I know that we have many people with questions, and I'm trying to solve them all, but as I'm doing the presentation, I'm not going to do that the very moment, right? So you will see my desktop, right? You can see now it's an Excel sheet, right? That's called budget estimation, right? And this budget estimation model, this is the one that I'm going to work with. So ModelRisk, as Timur well said, right? It's a fantastic tool for QRA based on top of Excel. You see, it's an add-on to Excel that sits on top of it. And there you have all these tools available, right? You have a way to generate distributions, output and inputs. You can do distribution fitting. You have more than 30 time series. You have correlations and copulas, etc. So it's an outstanding tool. What I'm going to do, I'm going to guide you through a very simple process, which is how is it that you can have a cost estimation model which has 70 items, and of course you can extrapolate this to hundreds of even thousands of items, right? Where you start with deterministic numbers at the beginning, right? These deterministic numbers, they give you like 9.3 million, let's call it millions, right? And the main idea of what we do at the Ferryfield Group with our partner, with Bose, is that we can help you set up and take a look to what we will call the uncertainty ranges, right? In this case, I'm going to make it very simple, and this session is for beginners mainly. Is what we try to do is we're going to try to set up a range around each one of the variables here, like this, right? So if you have a range for each one of the variables, what you can do is you can set up a distribution like the one I'm going to show you here, right? So in this case, for example, let me do it one from scratch. I can say I want a distribution. You will have a palette here. I can set up a per distribution, for example, and say, well, this per distribution is going to have a minimum, a mode, and a most likely, like this, right? It's very simple. And then you will have the distribution shape like this. You can overlay distributions. You can load all distributions from the worksheet, right? You can see all this descriptive statistics in the right pane. And of course, you can truncate, right? You have boundaries options here. You can set the static value, etc. And then you can just insert it to the worksheet. When you insert it to the worksheet, this is what you will see. You will see this Bose per distribution like this, and you can add a name with this Bose input command. I did that for all of them. And you see here that every time that I press F9, and if you focus here, right, If you focus here, that means that every time that I press F9, this is going to change, meaning that the total, the one that I'm going to highlight in yellow, is going to change like that. And this is what Monte Carlo simulation does, right? So if you're a beginner, of course, this is what it does. It generates, it fetches samples from the distributions that you set up, for the hundreds of distributions that we set up. And it says, well, I have a sample here and here and here inside the boundaries of the distribution, right? And when every time that it does it, it generates a new sample. So what the process does, the Monte Carlo simulation process does, let you run thousands of iterations, right? Meaning that it's like me pressing F9 many, many times and allocating all these results into a placeholder. And this placeholder is going to be called an output, right? And I already set up an output here, right? Like this, you see? I just have to enter the Bose output, or you can click here in the output and say, well, this is my output, right? This is the total cost. So you can run a simulation. I'm going to run it with 1,000 iterations. So this is what you will do. You see, I have a smaller model. Yeah, it's a different model where I have the same capabilities I was showing before, right? You have the deterministic, and then you will have the minimum and maximum ranges as you have here. And I just run a simulation. So after you run a simulation, you will get a graphic like this, right? Something like this, right? You can always change it for the histogram, or you can change it for the cumulative graphic like that, right? So what's going to happen is that you will be able to validate what's the difference between the initial deterministic model and the uncertain model, right? Which is this. So the initial model, remember, it was the 4.3 million. That's the one that we have now, right? That's the deterministic model. And normally the question will be, well, what is in this case, the probability that you surpass or that you are finishing in less than that? So in this case, for example, you have 14% probability of finishing before the 4.3 million, which is this left portion of it. And then you have 86% probability, which is, in this case, the right triangle, I will call it, right? The one that you have there. So this is what you normally have at the very beginning, right? Starting with the 4.3 million. Also, you have a way of taking a look to the minimum, maximum, which are here in the right pane. So you have all the descriptive statistics plus the percentiles, right? So what you can say is, besides the 14% that I have for in terms of the probability of reaching my original scenario, right? You also have, for example, probably the chance to say, well, what is my P80? So if you want to take a look and say, if you're selling this project, you can say, I will sell it perhaps in P80, or you're estimated internally, you can say, this is going to be my P80, meaning that the probabilities are going to be more on your favor, right? Otherwise, you're going to have only 14% probability. So this is the situation. Couple of things that you gain with this. Now you know that the minimum and maximum are between 3.7 and 6.5 million, like this, right? Then also you have that's the first thing, you have a range. The range, you didn't have the range before. Secondly, you have the probability of reaching out and surpassing or not your reference model, the 4.3 million. So now you have 14%, which is the second one. And the third one is that you can set up different percentiles knowing your risk profile, right? If your risk appetite, if you want to be in P90 or maybe P95, you will charge the client, or you will say internally it's going to be 5.9 million, or it's going to be 5.4 or 5.3, etc., depending on the level of risk appetite that you have. So only with this one graphic, you have all of these capabilities and reasonings that are going to improve your decision making. On top of that, and this is something that we love about ModelRisk, are the graphical capabilities. So in this case, I generated a tornado chart on top of the baseline cost, which is this, and this is telling me the correlation that it has, right? The typical correlation coefficients. Of course, we have more than that. We have another one, which is the conditional mean, that's going to be double-sided. You see, that basically saying that the main variable for the model is going to be the implementation of the pipeline. And this implementation of pipeline will be between the scope of that particular variable is going to be between 4.1 and 5.9 million, right? That means that when the implementation of pipeline is very low, you would expect the total cost to be around 4.1 million, and the opposite almost 6. The one that I like the most, and we always have discussions internal, is this one here, the proportional contribution to spread, because it lets you see and it just show very simply what is the driver of the risk, right? In this case, you have 95% of the risk is driven by the implementation of pipeline, right? So you have 8 different tornado charts that you have there, and this is only from a very simple model like the one I have here. It's a simple summation, and you have all of that coming together. The nice thing about this is that you have this interface where you have all these little tabs where you can eliminate those tabs like that, or you can add more. For example, if I want, I can say insert a box plot, and this box plot, what it's going to let me do is let me set up the inputs that I'm going to use. For example, I'm going to see the box plots for each and every one of my distributions like this. So you can see, of course, here, the magnitudes of the distribution. Of course, you can see that implementation of pipeline is very big, so that's why it's the main driver. Should I reduce implementation to pipelines, in this case, parameters, this is going to be totally different, right? You see that everyone is more or less in the same scale, right? Even I think the refinements and details as well, you see? So you have a very different view. And if you like, you can come here and say, well, I want this to be seen like this with the distributions like that. So it's a very nice visualization. You can always come back here, copy the chart, send it to a PowerPoint, etc. What else you can do? For example, if you like the chart, like the one that I have here, right, let's say that I like my tornado chart. So I come to the tornado chart and I go to link chart and I click here in new link chart. And this is going to generate the same chart that I have here, but that's going to be refreshed every time that you run the simulation, right? What else you can do in case that you have a model that needs to be audited, or you work with regulators, or you yourself are a regulator? What you can do, you can just insert here a data list like this, and this means that you will have access to the 1,000 or 2,000 iterations that I run, and you can click here and see which ones you want to see. For example, I just need to see the outputs, so you just need to see the outputs like that, right? And of course, you can right-click, copy all, and that's it, right? So that's going to be very simple for you. Now, what else I have in this model? In this model, what I did, I added a little calculations here. You see, it's a very simple model. I added little calculations. That means that I need to calculate the contingency, meaning that I have my P80. So I will go back to the results here, you see. We'll go back to the histogram and say, well, what's my P80? 5.4 million, you see, which is the same one you have here, 5.4 million. Now, what's going to happen is that for this particular one, right, it's 5.4 million, I say that my contingency, for example, is going to be, it could be the mean minus the P80. Majority of people sometimes take the deterministic minus the P80. I took the mean just because I wanted to show you some of the functionality that it has. So you can use what we call the Gaussian percentile or the Gaussian mean, right, in order to show it, right? And what I did here is I just did a simple subtraction, right, between them, right? Now, what I did, of course, at the end is dividing this contingency that I calculated divided by the 4.3 million, right? Again, I could change this mean. Imagine that I have this mean and I do this as equal to that. You can calculate this in a very different way. So it's up to you how to calculate it. The nice thing is that you have all these Gauss sim functionalities that you can add this directly in Excel, so you don't need to every time go and run and see the results and take a look to them before you go that. There's another one, it's called Gaussian probability, for example, Gaussian probability, right? That's going to take the 14% for the reference value. So the Gaussian probability, these are Excel functions, so it's an extension to Excel. So you can say, I want from this output, right? And this value, that's going to be the 4.3 million, right? Like this, it says no simulation results. That means that I will have to run the simulation again, right? And what will happen here, you see, now I have the 14% that I had before, right? So you have the ability to generate all the different, that will be like percentage of probability, right? All the different scenarios, you can generate these in Excel as well. So you have all these graphical capabilities plus all the graphical capabilities and the reporting in Excel. What else you have? That those are things that we really like about this, right? It's first of all, you can customize your ribbon, which is outstanding. You see that one for the former users of @risk, you see I have this @risk style. So you see that you have a resemblance here with the location of each one of the buttons because I configured my ribbon like this. Now, if you like, you can go to change it to, I don't know, corporate finance, or you can change it. You see that if I click corporate finance, you see that some of them are active, some of them are not, engineering, epidemiology, etc. And if you like, for example, you can build your own custom template. This comes with the software by default. It's outstanding, and that means that if you have basic users, that means that you can set up basic users options, or you can set up advanced user options, right? Like this. Then what else you have? You have a swap out modeling capabilities, meaning that you can take this model and you can send it to somebody else that doesn't have ModelRisk, and all of this is going to be, the distributions are going to be eliminated, but you're going to have which were the distributions that you use. So if you need to do that as well, you have a data viewer. That means that you can set up data views and see and explore the data that you have. You have a univariate, bivariate correlation analysis. You can set up correlation matrices from here, and you have plenty of other things, right? What else? Let me see. I don't think I will have the time because of that. Thank you, Doug, because I was looking at the presentation there, and we have a very nice video. And I'm going to, after the presentation, I'm going to share with you a nice video in the chat on how to select the right distribution. One thing that we can do here, and let me share this with you. Give me just 1 second. Is that you can easily fit distributions. So, and this is the second thing that I wanted to show you in the previous model. So let's say that I have all these distributions samples that I got here. Let's say, for example, from a sensor, from any information that you get. So let's say that I converted, right, like this, limited with commas, I guess. Yes, here you go. This one I'm not going to use. This one I'm not going to use. So yeah, I have this potential cost, or this could be temperature, or this could be productivity on anything, right? So what you can do, you can take all this information, 1,000 samples, you can come here to ModelRisk and say, feed it, right? Like this. And this is going to show you the observations, right? The real observations. And what you could do, you could say, I want to add all the potential distributions that could be of use here. And this is going to automatically do that, right? And give you the best distribution. So you have 3 different criteria where you can set up this distribution fitting as well. So you can change the order of each one of them. For example, and I can set up and say with a visual inspection, I can say, well, let's see how these first 3 go. Maybe I will go with the beta distribution because I'm not an expert in the log triangular, but it looks really nice. So I can go to insert to worksheet, not link to data because I don't want it to be linked with data, but you can do link to data. That means that if you have, for example, a feed, let's say a Bloomberg feed or a Reuters feed, and this changes every day, the distribution fit get changed every day as well. So you can see that now I have a distribution here. So I think that with this, I would like to finish the presentation. Again, thanks for the patience because the model was corrupt. Of course, it needed to be corrupt. Just as a quick anecdote, I showed the same model in a ModelRisk demo yesterday, and it didn't have any issues. But you know how this is. So morph is everywhere. So I will respond questions in the chat about this, and for everybody asking for the recordings, yes, you will have to fill a form that Craig and Doug are sharing. And if you like to see more videos about more advanced features of that, we have a library with that. I will be sharing that with you as well. Normally, you will be able to generate the sensitivity graphics like this, or if you like, you can set up the scatter plot like this and change and choose. For example, I want to see implementation versus the total baseline code. You see, I knew it because it was the biggest one, so that's why I had it like this. So you can set up a scatter plot like that, or if you like, you can set up a tornado chart. What happens if I decrease the numbers here? Let's say I shave it in half, 750 and 2 million, right? I run the simulation, and that will be a good sensitivity analysis, right? And you see that now, instead of 95%, you have 88%. You see? And now the others start to get relevance. Why? Right? But you have a different tornado chart. Right? Now, what you can do, you can set up this as a, again, remember that in the first one, when we have twice as much as the value in the implementation, we have like 4 million here and 6 here. And now that we shave it in half, we have 3 and 4. Most likely, as we decrease the model's value from implementation, my histogram, you see, now my 4.3 million has a 98% probability of happening, you see? So if of course, if I was able to manage the implementation to be cut in half, right? That means that you will be able to have this you will be in a very good position, right? So that will be a good sensitivity analysis, right? You can always set up this as a Pareto chart like this. It depends on what people like. You can show the sliders or not, or you can show legends if you're able to take a look to that. So I think that that's something that people wanted to see, right? In terms of the sensitivity analysis. Let me see in the chat. My recommendation, because I see that some people had issues at the beginning with MS Teams, don't use it in the web browser, but use it in the main application. That's going to give you all the capabilities that we have now, where you can see multiple screens and you can see all of that. Otherwise, it's going to be a little bit difficult in the web page, because the screen rate, it's not perfect. In the application is much better. So my recommendation would be, if you can set up in the application. I think, Craig, some people are asking for the form, the Excel model. I mean, I can share you with the Excel model, but I mean, I will take a look to the model. So I'm not going to share you the failed Excel model that has some issues with it. So yes, we're going to share a complete folder where you will be able to see the videos. You're going to have the presentations, and I'm definitely going to include this model. But I will include this small one, which is very simple. Now, a couple of things that you have in this model, if you have 5 more minutes, we have a hidden sheet, yes, here, that has a risk register, right? And in this risk register, what we did, we generated the typical risk register structure, right? Like this, you have 5 risks. You have, if it's multiple, it's going to use a Poisson distribution. If they are single, they are going to use a Bernoulli distribution, and they are going to be aggregated here, right? The VOS has a solution to the convolution of distributions, which is called VOS aggregate MC, which you have it here, and that basically shows you, right, and lets you combine the frequency and a severity distribution. So this is something that you have out of the box in the model. You don't have to have anything additional, and it comes with the software, right? So what I did here is this. I added this risk register. I can add it in here. For example, let's say that I want to add the risk register. So I can add an additional line here and say, well, I want my risks to be included, right? Like this, right? And then just have to change it to F13 like that, right? Then I will have to run it again to include, you see the operation of the software, right? So now you see that it changed a lot. Remember that we were in 98% because we shaved in half the implementation, and now we're going back to 69% because we added the risks. So the nice thing of the tornado chart, and this is something that I really like about ModelRisk, is that, for example, here I can add my total baseline cost, but now you're going to have some of the risks. Implementation is going to be the first one, but here you will have, for example, resource scarcity, final delivery, problems with community, etc. So in the same tornado chart, I was able to add additional risks that are, of course, impacting in my total. Right? If I like, what I can do is I can see the total impact of these risks in the total cost without taking a look to the cost. So I can just isolate them like this. And I will say, for example, here, in terms of the total cost, I'm going to isolate them and take a look like that, right? So these panels that you have here at the left and the right, yeah, these are the key portion of it, right? Because they are really flexible and really let you use it like this. You see, so in this case, you can say that resource scarcity and the exchange rate exposure are both responsible of 80% of the risk, right? From a very simple model like that. So those are the things that I really love about the tool. So I think that I answered a couple of questions there. Is it possible to share the Excel model? Yes, of course, Fernando, more than happy. You can add correlations, and with that I will finish, and I will go to the proper pause. For example, you can set up here uncertainty. I set up all the distributions like that, and what I can do, I can say here correlations multivariate, and this is going to generate automatically a correlation matrix with this 0.9 coefficient. Of course, you can change it. You can set up labels here like this. All right, like that. You see now you have the labels. And what you can do, and this is something that I really like, is that you can see which are the percentages from where the correlations are being fetched there. So I'm going to put the correlations matrix here, like that, and insert it. Let me see. Oh, I didn't. Let me see here. Okay. So what this is, you see, this is the percentile from where each one of the distribution samples are obtained. So if you have a distribution A and B, and you're doing correlations, that means that A is fetching the correlation from here, and B is from here. If I do it again, you see that now they normally they are built in tandems like this. You see every one in more or less middle of the distribution, very low, low, middle. You see why? Because we have very high correlation coefficients. Should it be very low, the correlation coefficient, this is going to be all over the place. So that's what you can do here. So thank you so much for all the questions that you have there. We're going to do the effort and try to answer all of them in a document next week, because I think that you're going to have really good questions, and I know Doug and Craig have been answering them. And I think, Craig, we're going to go to the proper pause now.